Hello and welcome to Dr. T's Math. In this video I'm going to go through a couple example commands from the TI-84 emulator. This here on the screen is basically the same setup as a TI-84 80 blank series. It's got all the same keys and most of the same functions. So say you're taking the ACT test or something like that and it asks you for some log that's like log base 8 or something that is not a log base 10. Then you can calculate that pretty simply by going to math, and then you're on the TI series you're going to have to arrow down to the C there, log base, and then say it was log base 2 of 8 and you didn't recall off the top of your head that 2 cubed is 8, so then you could calculate the log with a different base. Whereas if you had just a general log of say 1,000, that log key down there next to the 7 is actually log base 10, and so you can change the log base using math and arrow down to letter C and say we wanted to just confirm that log base 10 was 1,000. We'd put in log base 10 and then 3, log base 10 to the third is 1,000. There we are, 3. And then say you are doing something with derivatives and you want to calculate the derivative at a certain point. Say you've got a function, I don't know, maybe x raised to the third power, and then we'll say plus 2x squared, and then minus x plus 3. Yep, plus 2x, sorry about that, minus 2x plus 3. And so we graph it and we get something like that. Well, on the emulator here I've got d dx right there, and it's just going to do it for me. Now on some of the more recent versions of the TI-84 you'll be able to get that right on the screen, but let's say second and then function, so second calc, and then we can say value d dx where x is equal to, we're going to have to choose an x value. Let's just say x is equal to 6 since I see it right, or x is equal to 1. We'll just say x equals 1. And press return, calculate, and it's going to give us the derivative for this function right there when x equals 1. And say we wanted to figure out, well, what's the relative minima there? Similarly, we could go back to the main screen, press second, and then function or calc, and we're going to go minimum, and it's going to give us our bounds. So this is somewhere between x equals 0 and x equals 2, and so it's going to tell us what that x minimum is there. So at 0.38 on the x, we're at negative 2.58 on the y. Now unfortunately it won't give you the derivative in equation form, but if you know the power rule, you should be able to solve something from those polynomials there. And finally, let's look at, say you wanted to look at the integral. So again, we go math and then down to the integral, and it's only the definite integral, unfortunately. It's not an indefinite integral. So you might, on the ACT or something like that, you might have to actually know your rules for integrals because the TI series isn't going to do it for you. So let's have a look at something like the integral from oh, look at that, symbolic integral. Now on some TI series it won't do that for you, but let's have a quick gander and see if it does that for us. So we're going to have x squared plus 1 dx, press enter, And it's going to give us, in fact, it does do the indefinite integral. Well, that's real convenient. And then on the older TI series, you're going to have the fn int, which would be the definite integral. And so let's take that same function from, let's see there, from 1 to 2, and it's going to be x squared plus 1, x squared plus 1, dx. Press enter, and it gives us the symbolic integral, and then also the definite integral, which is what we're really looking to get there. But let's make sure that we put that into parentheses. So let's get from 1 to 2 of parentheses. X squared plus 1, in parentheses dx, press enter, and that's better, 10/3. And so in future videos I'll be looking at still more commands on the TI series, in case you were wondering how to use this thing. Okay, thanks for watching.